Welcome to machine learning algorithms. So we have taken here SPCU, SPPU B computer syllabus LP3 class B uh, problems, and this is the second problem of class B of your B group. So in this classify email into two groups, that is spam and non-spam. So that is the normal state of a email and abnormal state of the email. So email classification is a binary classifier we are going to use because we will normal state as 0 and abnormal state as 1. So therefore a binary classifier will design based on k nearest neighbor algorithms. Dataset used is email data from Kaggle, which is available here. So in this problem there are two actual problems. One is a email classification, email processing, which is nothing but a text processing, and the second one is to apply that classifier. We are going to use the k-nearest algorithm. So first we'll see how knn works, and then we'll see what do you mean by email processing, because once the text within an email is processed, then only we can classify it using the classifier. So let's start with knn algorithm. So k-nearest algorithm, mm, it is said that it is easy to implement. So, so it is easy to implement because it is simple in coding and understanding, and its accuracy is more. So generally, it is used as a first step in classification. It can adapt the different parameters, different features for classification very easily because it is based on a distance. So you have to specify on which attributes a distance is going to apply, and then it will work accordingly. And for every new samples, it is finding the distance. So there is no need of a training or parameters which should be set earlier. So it is a non-parametric type of classifier. So if you see, there are very few hyperparameters you have to set while calling the KNN algorithm. That is the value of how many neighbors you are going to count. That is the value of k, and which distance metric you are going to use. Whether it is a Euclidean distance, Hamming distance, or like that. So that you have to give the parameters. So only two parameters are sufficient to use the k nearest neighbor algorithms. So for every classification of a new data, all the test points are in a memory. So that's why it is called as a lazy algorithm. In terms of it use more memory, as all test data set is available in a memory, and it does the comparison of all those test points with a new one. So it takes a lot of time to learn the new class. So that's why it is called as a lazy classifier. It has got another disadvantage. It is a curse of dimensionality. Means for increasing the accuracy, if you increase the number of attributes for comparison, then it becomes slow. And all those attributes should be present in the memory, so it takes more memory. And it is prone to overfitting because it depends upon how many k you decides. So if the k value is lower, then overfitting may take place. While if the k value is higher, if you consider high k, then many points are taken for classification. So therefore it will smooth out the prediction. It will spread over large set of k values, k neighbors. So underfitting may take place when you I should take higher k. As a thumb rule, we generally take k as odd value because finally to decide the class, it takes voting of majority voting. So therefore we have to take it. It is better to take odd. So feature of KNN, you can assume that it is a non-parametric supervised learning, and it is a distance-based classifier, proximity of classifier or distance-based classifier. So it works like this. So if say these are the test points and a new data item, we have to find out what is the class of this new data point. Then we have to find the distance of each test point with this one with a new data point, not only near it but distances of far away point also. This similarly for green also, distance with this atom, this test atom, and every test atom is pre-classified, supervised. So greens are no and red are yes. So these are the two classes which are already defined for class. So we are finding the distances with each one. So say D1, D2, D3 like that. So say we will now make an array of distances while we find the comparing the distances. So say there are 10 points in a test. So those distances with the new data we'll find out. And then the next stage into KNN is it we have to sort it in ascending order. So the smallest distance say D5, then D7, then D8, then say D2, then say D1, then D10, D6, say like that. So this is in ascending order, and then we will find the class best by taking the voting of the first k. So if you have set k equal to 5, say then first 5 we take for comparison. So if the class of fifth say S, 7 is S, 4 is no, 2 is no, and 1 is again S, then the majority are S. So the class of new data atom point is S. So that way we'll assume we will find the we will apply the KNA. So in the first stage, we have to calculate the distance by comparing, by applying any metric for distance. Then in the second one, we have to sort it in ascending order. And in third one, we have to find out the uh, first 5 or first k atoms. And we have to take mm, majority voting on that to decide the final class of the atom, newly added atom. So this is what is the process of KNN. So the same thing is defined here for each point in test data. So that is important. So it compares every test data. So that's why it takes condition is that all test point must be in the memory, and for every one there should be a comparison or finding the distance calculation. So that's why it takes more time, but it doesn't need any training. So first we have to calculate the distance between it, training data and the test data. Training data. So that is the distance D. And you can use any method to calculate the distance, Euclidean, Manhattan, or Hamming distance. Then based on that distance value, you have to sort the distance array in ascending order. Then choose the top k, whichever k value you have decided on this sorted array, and then assign the class based on majority of the votes. So these are the steps in 4 steps in k-nearest, and that is done for every new atom added into the for classification. So whenever the new data item comes, all comparison will take place, all sorting of the distances will take place, and the new class will get decided. So now we'll see email classification. For email classification, we have to do first the text pre-processing. So for that, we will get a natural language toolkit available in uh, the Python. So that is called as NLTK libraries that we have to toolkit that we have to import, and that helps you to process the human language data, and that is called as NLP, natural language processing. So uh, language processing is used for text processing, which is done by tokenization, parsing, then classify, and then classifying into different words, then stemming the word, means converting them into the root meaning, means removing this ing or s like that words, and then tagging them based on semantic reasoning, so that we will get the different words or sentences out of the text available with each one, and then we classify by finding the distance of that text with a different text, and that distance will give you the class of the new text. So this natural language processing on NLTK toolkit is available for text classification, chatbot, semantic analysis, or language translation, whatever the things which you will use for machine learning, that you can do through this NLTK. So important one in text processing is text tokenization. Text tokenization means converting the paragraph into some little tokens. So these tokens you can convert in two types, that is word, in terms of word, or in terms of sentences. So there are the two tokenizer available. In word tokenizer, each uh, word is taken as a separate entity. So the paragraph is converted into the word. While in case of a sentence tokenizer, each sentence is taken as a one token. So for example, here we have taken a text as God is great, I won the lottery. So that either I can convert into God is great, then this explanation, then I won like that, or I can use the sentence tokenizer, which will convert into two sentences, that is the word God is great and I won the lottery. So that can be these are the two sentences available for processing. So you can go for sentence tokenizer or word tokenizer, and that means take a smaller unit as a sentence and then process, or smaller unit as a word and then process the text. Then there are two important processes which should be applied for before text processing, and these are the stemming and lemmatization. These are the two processes which are done for text processing. So stemming means converting every word into its root word, because say you may be using ing with the stem, or Asian lemmatization, so that you can use with the basic word limit. So those things are done by stemming. So longer words are converted into the short word or root word, and those will be processed easily, or meaning can be drawn from that. For example, eat is a root word, and the variations are eats, eating, eaten, like that. So all those are stemmed into the one word called as it. And in lemmatization, every tokenized word, means that word is uh, converted into the meaningful word terms of a context in which that word is used, because the meaning may get changed because if you know the context. So lemmatization is a process where this tokenization of word is done in terms of the context in which it is used, so that the meaning will remain same in terms whatever it is used. So for example, stemming for studies, studying, cries. So that is study, that is the basic word that you will using, and for cries and cry it is used. Another important tagger is average perceptron tagger that is used into the from NLTK, and that is the punct. So this tokenizer is based on parts of speech. So it tags the words depending upon in which part of speech they have come. So that is also we have used in email classification. So let us start with the data set. So we are going to use a Kaggle data set, that is spam ham data set, which is of 5.5 MB, and it has got only four attributes, that is the label, text and label number, and the number means row number. So labels used are ham and spam. So spams are 29% and ham means clear emails, good emails are 71% available into that. And email data is totally unique valid are around 5,000. So we'll start with Colab, or you can use your own local um, Python compiler. So first we'll do is loading the standard libraries like NumPy, Pandas, Maths, and Matplotlib, and then we will upload the file using the upload method. And our data set is spam ham data set. So which has got the characteristics of 5174 rows and just four attributes, that is the unique number, then label, text, and label in terms of no integer, that is either it is 1 or 0. That way we are going to use a binary classifier. So then in the next step we will drop unnamed emails, but there are no unnamed emails. So total 5171 rows are available for uh, processing, and total values in that, out of that 5171, hams are 3672 and spams are 1499. So this is a totally unbalanced data set which may hamper your algorithms accuracy. Now in data pre-processing is nothing but text pre-processing, as I discussed previously. So first uh, the punctuations are collected in pre-processing, and then the cleaning method is uh, written here. So cleaning is nothing but we will remove the first we will remove the we will convert all text into lower text. Then we will remove the spaces, tabs from the new line spacer like that from the text. Then we will remove all the links within the email. Then we will remove the special character also, and we will take only A to Z and 0 to 9. Then we will remove the punctuation used in the email. Use single letters like A and A, B like that if they are used, or 1, 2, 3. Then we will remove the numbers also. Then we will remove the multiple spaces if they are used in the while writing the mail. So by removing this different uh, characters, we'll get a clean text with the words. So If you see, when we apply that method here, apply cleaning, the you will get a text called clean text. So first text is like this, where colon is used, spaces are used, commas, hash, numbers are used, or there may be a multiple uh, spaces, curly brackets. Everything is removed by means of our clean method. And clean test is like just words, subject, enron, methanol, meter, this is like that. And a single words are also removed like s, a, I, all those are removed from this class. So we now have got clean text, which is just of words. Now we'll remove stop words, punctuation, like that from the that clean text. So if these subroutines or libraries are not available, you can download them from the NLTK website. Then we will use the lematizer. So there are different lematizers available, but we will use WordNet lematizer, which will remove, which will separate out adjectives, nouns, verbs, and from the text available. The text lematizer is applied here by means of a do lemma method, and we will now get a clean text in a database. So there are two methods we are using. That is a clean text. Now we'll call it text and label applied to that email. Now using train test split, we'll convert it into a test and train uh, databases. Two databases will be generated from the same one. X train, X test, Y train, Y test. Label are also train and test and train and randomize, with 20% is used for testing and remaining 80% for training. We will use k neighbors classifier, which has got just two parameters we have to set. How many neighbors you are going to use for last finding the class, and which metric you are going to use for distance calculation. So Euclidean distance generally use. So that will find the distance between test and newly uh, test emails and newly added email. So that will use based on Euclidean distance. So we will fit it into uh, using training data for this k nearest neighbor classifier, and then we will test it on test data. And now we'll check the accuracy of train and predicted and the actual test one. So that comes around the accuracy score using predicted by means of our algorithm, and Y test, which is actual class. So 96% emails are correctly classified as spam and non-spam. So this accuracy is good for k nearest neighbor classifier for emails. So thank you for watching it. Do watch other classifier also.